When it comes to evaluating your method, everyone needs to learn this skill. There is not an adult alive in their everyday work life that doesn't have to evaluate what they've done and try and improve it or think how they would improve it for next time. So this is a skill that is essential for all modern day 21st century workers, evaluation and reflection so that you can improve. So here's the scene. We're in our detergent prac. We've got some kids who are comparing different types of detergents, and the way they did it was they measured out the same amount of detergent from each brand and they added it to a mix of oil and water, and in that mix you had the same amount of oil, same amount of water, and they mixed them all up, and then they measured how much oil was actually left after the detergent had been mixed in, so how much had actually been broken up, how much was left. So they had a few issues with their method. I'm just going to draw a few of these issues out here so you can understand. So let's look at the first problem they had. They used a 50 ml measuring cylinder, and all they were trying to do was measure amounts of less than 10 ml. Now if you look at a 50 ml measuring cylinder, the very first little increment on it is 10 ml. So how on earth did they end up measuring accurately 10 ml, 7.5 ml, 12 ml, 8 ml, and so on and so forth? The fact is they couldn't have. It wouldn't have been very accurate at all. They used the wrong measuring cylinder. In order to do those sorts of measurements, you have to use a measuring cylinder that has the appropriate increments on it that you can actually use to measure it. So they should have used a 10 ml measuring cylinder. Basically, their data wasn't very well measured at all. So another issue they had was different students taking turns to measure out the detergents and the oil for every trial. Now the problem with that is that everyone measures slightly differently because of how they look at the measuring cylinders and stuff, which means you'd have a little bit of variation for every person who measured it. If you're trying to get an experiment to repeat the same type of measurement over and over and over again, you should use the same person. So that in itself introduces a bit of error. The other thing is that only had a couple of trials. Now, how do you know if you're able to repeat something and get it accurately measured if you only measure it once or twice? You've got nothing to compare it to. If you want to make sure that you're measuring something and doing it properly over and over again, you've got to do a whole heap of trials of that same group, that same measurement, in order to compare and see if you're getting the same result over and over and over again. So that also meant that they weren't able to see how much error they had in their data. A few other things. They ignored the obvious error that came up when they did look at their data. If you do see error in your data, if you see that for the same measurement there, someone measured it at 8 ml, someone measured it at, say, 7.5 ml, someone measured it at 8 ml, and then someone measured another one at like 5 ml, well, you can see there's obviously some error in your data, and really you should actually cancel it out, write a little note to try and explain why you cancelled it out, but not use it when you're determining your averages, because if you do, it's going to really stuff up your data. So when you see error, you need to take it out and account for it, but not include it in your averages. So they're the general overview of the big mistakes they made in this experiment. Now let's look at how you write an evaluation on that. So let's look at how we actually write up this evaluation. For a C level in ACARA, that's the blue over here, you need to just be able to tell me how you would modify the experiment for next time and talk about how this could improve the quality of your data. So no reflection is finished unless you relate back to how it's going to improve things. Okay? So they're the two parts for any basic evaluation. To get the B level or A level, you have to first tell me, okay, this is the error I saw in my first method, and this is how I'm going to try and improve that error or fix that error or get better data. So you have to actually point out the errors in the first method and then tell me how you're going to change it in your new method. That's the difference between a C and a B and an A. The only big difference between a B and an A is how well you explain that. So for a B level it says effective modifications. So you can't just tell me any modification. It has to be one that I know actually would work. It can't just be something you've added in there, and it's not really a great change. For an A-level, you need to tell me very thoroughly how it's going to improve your method, why it's going to get your data to be more accurate, more reliable, more valid. You have to really show me you've thought about why that change is important. So let's go and have a look at some examples. So for a C-level, they first have to tell me how they'd modify the method, and then they have to talk about how it would improve their data. So they've said, I'm going to measure the detergent more accurately. So yes, they've said how they're going to improve their method, basically. And how is this going to improve their data? Well, it will mean we'll have exactly the same amount of detergent, and it should also be oil there, but detergent, to break up the oil, so they can be fairly compared. So that basically meets the C-level standard. At least there they've got the detail for what we've asked. So how does a B or an A-level student improve this? Well, first of all, they have to point out where they saw the data had error, and then talk about how they're going to fix it. And remember, the difference between a B and an A-level is how thoroughly you explain yourself. So the green is B. This person has said that trials in the same group, so this means for the same detergent, had a lot of variability in their answers. They didn't get the same answer every time. So that's definitely got some error in there. They've gone on to say that if they use the same measuring cylinder and the correct size measuring cylinder, that the amount of oil and detergent would be the same, or at least better in their measurement. So I've identified the issue, lots of variability in the group's answers, and I've identified how I'm going to improve it. Use the correct size measuring cylinder, same measuring cylinder even, and I've also talked about how that's going to improve my data. It will allow each trial to be measured the same. So that would be a B-level response. Down here they've also talked about here the different students, how allowing different students to measure, there we go, would also mean that there are slight changes in their measurements, in their data. So how do we fix that? The same person should measure all of the reactants. That means that the trials should actually be more the same result if the same person measures it each time. So that's what a B-level person would do. An A-level person would add a bit more detail to that. So in here, the A-level person, instead of just telling me there was variability, they showed me what the variability was here. 7.5 was the average, plus or minus 2.5 mil. That's huge. That means their smallest measurement was 5 and their biggest was 10. So that's a lot of variability there. They've also gone on and been a bit more detailed when they tell me how they're going to fix it. B-level said same measuring cylinder and correct size. A-level said 10 mil instead of 50. More detail. Also, when it came to the different students, they've detailed that different students would have different measuring technique, how they used it, and that this would allow us to have the same method each time if you use the same student, and it would mean that we would have better repeatability in our results because we're using the same student. That in essence is the difference between a B and an A-level answer. So use this demonstration here to try and now apply it to your own evaluations now and see if you can practice that skill.